Hello everyone. We have a global challenge to fight together, and that is climate change. And in this presentation, we'll describe how an industry, the energy industry, can start to collaborate around data, software development, and data science. We will present why the smart energy collaboration exists, and what business value we are addressing, and what capabilities we're building for the energy companies, and how we speed up the data science lifecycle through collaboration. This picture is taken almost exactly 2 years ago, the 28th of August, on a hot summer day. We were gathering indoors, which feels a bit unusual nowadays. But this was the first time a number of energy companies met to form the Smart Energy collaboration. And the Smart Energy collaboration consists of 12 energy companies. And in addition to that, a number of universities for the data science parts. And we who present today is Henrik Gadd, business developer at Öresundskraft, one of the most innovative energy companies in Sweden, together with some of the others in the Smart Energy group, actually. Henrik is a PhD in energy data science, and he's also a member of the data science board and the development board in Smart Energy. And Solita is a strategic partner who is facilitating the collaboration both by contributing to the business vision, the legal and financial setup, as well as contributing with DevOps team and data scientists to the team. And my name is Anders Tholén. I'm working with strategic business development at Solita. Over to Henrik.
So, why is district heating one of the keys to solve the climate change? I will start to present some figures. For residential energy consumption, about 80% of the energy goes to heat. In 1960, 99% of all heat generated in Sweden came from fossil fuels. Today, about 60% of the heat market to buildings come from district heating, and from this heat, only 5% of the energy comes from fossil fuels, and it's decreasing every year. The energy industry is now planning to introduce CCS technology to become CO2 negative in the coming years. If we look at the market share for different heating technologies in Sweden, the latest 50 years, we can see that fuel oil, that used to be totally dominating, are more or less extinguished for district heating, for building heating purpose, while the market share for district heating has gone from 0 to about 60%. The remaining part is split between electricity, heat pumps, and firewood. So heating or district heating is the main heating for buildings in Sweden. The basic idea with district heating is to use low-grade heat sources for building heating. What makes district heating smart is that you connect buildings and heat supply to one system where heat can be shared depending on if you have lack of heat or excess heat to share. The energy companies is in transition from energy producers and distributors to become a marketplace where more and more important task is to match and balance demands and supplies of energy. We see a development where the buildings we see in the top in this slide will become both energy users but also energy suppliers. We have heard about electrical smart grids, but now it's time for smart heating grids as well. So why is Öresundskraft entering this energy industry collaboration? What's in it for us? We can see that we need to be more effective to be competitive in the future. And one part of that is to become more data-driven and to optimize processes. By building competence, exchange ideas, and develop software together with other companies, we can share the costs. The district industry has been and still are a collaborating, friendly industry and has long experience of collaboration. The collaboration with a large amount of high-quality data collected attracts researchers and other skilled persons that can be hard for single companies to attract. So these, I would say, is the main reasons to us to go into the smart energy collaboration. And now we will look for some of the values that we can see in the practical values in the collaboration. This is a picture of a major pipe failure. This is occurs rather seldom, and it's easy to find, and you can realize that we don't need a data scientist to identify this leak. But there are also some smaller leakages, and these are today very hard to detect. It can actually take years to detect it. And we are at the present working in a project to try to detect this faster, and so far it's looking pretty good. Another thing that we can do today is to detect faulty heat meters. For decades, this has been a problem, that some heat meters over time measure less and less energy. This change is very slow, and it's impossible to detect with manual methods, especially since many heating networks got thousands of connected buildings and thousands of heat meters. District heating systems are, on the customer side, very forgiving for faults. But these faults often cause inefficiencies in the distribution and the production side of the system. But the customer doesn't notice these faults. The building is warm, there is hot water in the tap. But as I said, it's a problem for us as a company because it creates inefficiencies. Typical faults could be malfunction of moving parts like valves and pumps, but also broke sensors and incorrect systems in the control system could be a problem. And this illustrates the reason why we need to optimize and use data science to identify these faults. Many of them can be identified or has historically been identified, but it takes often very long time. It's months or years. With the methods that we are developing now, we can identify them in weeks or even days. Other faults have been very difficult or impossible to identify in the past, especially if you consider costs. It's problems that is too time consuming to look for. With optimized analysis, we now can identify faults that earlier was actually impossible to identify. And this is also a theme for future research and development. So to summarize, by analyzing meter readings from heat meters, we now have a possibility to detect faults earlier, but also to detect faults that previously was in practice impossible to detect. This means that we can save money, but also that we have an improved customer trust and an improved customer satisfaction.
So what are the challenges traditionally in the Swedish energy industry when it comes to data science, and why does it take so long before we actually can get the results of data-driven research and get value out of it in the operations? Well, to be successful, with data science, you need to organize a number of competence and capabilities together, and traditionally energy companies have collaborated with universities, provided them with some data to investigate something, to create some type of value out of this data, energy data typically, to find, for example, deviations or faults or optimizations or forecasting models. And then the researchers worked, and maybe after 1 or 2 years comes up with a report. But then it's a big step to actually get some value out of that in the organization and to the customers. So that's one of the major challenges, to actually make it into something that is used in the organization. Secondly, something called AI, and AI Jesus comes to solve all our data problems. But to do that, you need to have a combination of data and domain understanding. You need to have access to data, which is findable and understandable and accessible. It needs to be tagged normally if you want to train your models with it. And you need to have some kind of process to actually roll this out into production, to operative use. And so you need to establish quite close teamwork between scientists and domain experts and software developers. And as you all know, problems to access and understand and have quality of data often consumes a large share of research time and budget. So these are the challenges that we want to address in this collaboration. And we were thinking a little bit like Kaggle for the Swedish energy industry. So we have defined 5 cornerstones, which we'll now describe in more detail, for how we can speed up the data science lifecycle in an industry. And first of all, it is the collaboration model to set the co-financing model, the Hyperight model, and say prioritization framework to define the roadmap for what to prioritize. The second thing is to have an application, in our case called K2, for applied data science, which is rolled out and used, and where each new version can contain new analytical models that are rolled out. Third thing is to collaboratively manage data and standardize data together. So to define fault label taxonomy, and that's what we've done, that you can use to train your models with. To define a common semantic information model, and to classify information from a security perspective. And then we've built a data science portal where we're publishing analytical challenges and datasets, and also proposed analytical methods, algorithms are presented and discussed. And from this, then we select the best working analytical methods that are built into the K2 application. And to enable all this, we are also had defined a data sharing framework to make data available for the data scientists. So we'll now describe this in more detail. If we look at the collaboration model, the energy company is out here. This is where we want to create the value. Here we have the smart energy collaboration, which we've been talking about, which started 2 years ago. And here is the data science collaboration involving all the research institutions as well, and 32 energy companies in total. What we've done is that we've initially established the DevOps team to develop the K2 application. And we've then extracted data from K2 into a common data lake that is used for the data science initiative. And in the data science project, we have then built the data science portal, and we have data scientists from different places and a core data science team working with defining analytical models and then selecting analytical models that are built into the K2 application and then rolled out into the application, which is already installed at the energy companies. So this is the way to really speed up the data science lifecycle for the energy industry. So what is then K2? We talked earlier about early detection and to find hidden faults within. It could be faulty meters, it could be faulty substations, it could be energy leakage, etc. And what K2 is then doing, the current version, because this is improving all the time, it's automatically detecting patterns for each prosumer's energy usage, for flow of water and temperatures. And then it has algorithms for anomaly classification, alarm generation, and scoring. And it's a combination of visual analytics, but the mathematical models and the algorithms supporting sort of digging into the data and finding the needles in the haystack, the anomaly needles. When it comes to data standardization and information management and information modeling, we have defined a data dictionary with clear definitions of terms and concepts, and defined value sets and hierarchies. And these are then continuously reused by business data scientists and software and API development to improve clarity and increase speed. And we've also classified different objects with the ISO 27000 according to that standard, and to use that for the data sharing framework. And we have used the fault label taxonomy and the analytic value matrix to basically first estimate the frequency of each type of deviation and fault, and then to estimate the value of early discovery and ability to find using analytical methods. And then we have not finalized this yet, but we're starting to measure the frequency of the different type of errors and deviations, and actually measure how good are we at finding these anomalies early, and what is the value that we then generate, so we can actually measure the value of our application in operation. And the data science portal is the sort of the node for the data scientists, where we publish data sets and analytical challenges, and then present different type of models, analytical models or machine learning models, and present and publish the results and discuss those results. And this is published in notebooks, so it's a combination of code and documentation, and it's executable code, so others can try the code, they can change the code, and so on as well. So this is a really good way to get the data scientists to work together and improve the speed of the data science work. So to summarize, why do we have an industry collaboration between energy companies? Well, they have to a large extent the same challenges of becoming more data-driven, and together we are stronger, more innovative, have more data, we get more value for money, we can control our roadmap ourselves. It's not dependent on individual software vendors' plans, and we own what we develop, so there is no risk for vendor lock-in or vendor data lock-in. So to summarize the overall picture, as Henrik described before, we in this new sort of in a future sustainable and digital world requires a lot of new capabilities from the energy companies. They need to move from being energy suppliers to actually facilitate this new and balance this new energy collaboration economy. It's a sharing economy, where each building or vehicle could store energy, could deliver energy, or could consume energy. But this is a balancing act, which is quite complicated. You need to have prediction models for different weather scenarios, if it's hot, cold, windy, sunny, etc., and know the different patterns for different type of actors in this system. And you need to use the data for predictive maintenance to reduce energy leakage, to reduce faults in this system as well. And you need to address information security and cyber security in this too, and compliance. So those are the Those are the sort of main opportunities and challenges. And to do this, energy companies to build up 3 core capabilities. It's the 3 I's. It's information exchange, it is information management, and it is intelligence. And this is basically what Smart Energy is, the community and platform for Swedish energy companies to do this, to support this and enable this data-driven journey together in a vendor-neutral way. Thanks a lot.